Hey everybody, Mr. Covey here, and today we're going to go over real quick 10-2 number 29. Cool. So it gives us this parametric, x equals 4 secant of theta, y equals 3 tangent of theta. It's just asking us to use a graphing utility to graph the curve, and then eliminate the parameter, okay? If you want to use your graphing utility to graph it, you literally just grab your graphing calculator. Make sure you go to mode, go down to parametric mode, hit the y equals, type in the equations. For secant of theta, how do you type a secant in the calculator? You do 1 divided by cosine. Cool. Okay, I'm using t's instead of thetas because that's what they're asking me, but it doesn't really matter at all. 3 tan of theta, toss it in there. That's what the graph looks like. Now, something weird is happening here. And I probably need to check on my window. So if you click your window, remember that you want to say what t-values to graph. So this is dealing with trig. I'm going to graph t-values, theta values. They don't tell me what to graph. But I'm going to go from 0 to 2 pi. It's always a good guess. Okay? And I'm going to click graph and see if it looks a little different now. Still looks kind of crazy. I hope that you kind of see what was happening there, especially if you use that ball and chain like Miss Lemke likes to use. This guy might help us. It goes over there, over there, over there. What's happening when it's shooting really quickly is we're having some weird asymptote situations. Okay? So really the graph looks like this and like this. The converting it to rectangular will help us. You can see what it exactly looks like. How do you convert this to rectangular? Well, we're going to need to use our Pythagorean identities. If you don't remember the other ones besides sine squared plus cosine squared equals 1, remember that you can take the sine squared plus cosine squared equals 1, and you can divide it all by either sine squared or cosine squared to get the other identities. I'm going to divide it all by cosine squared. It's going to tell me my other Pythagorean identities. Sine squared over cosine squared. Well, that's tangent squared. Cosine squared over cosine squared, that's 1. 1 over cosine squared, that's secant squared. Okay? So now I got this formula that's an identity relating sine squared or tangent squared and secant squared, and I'm going to use that to my advantage here. So I'm going to say x divided by 4 equals secant, y divided by 3 equals tangent. So using that green identity, y divided by 3 squared plus 1 should equal x divided by 4 squared. If you want to rearrange this so it looks more familiar, you get this. X over 4 squared minus y over 3 squared equals 1, or x squared over 16 minus y squared over 9 equals 1, which is a hyperbola, which is what the graph we had showed. It was a hyperbola. Okay. All right, that concludes this problem. Thanks, guys.